We're given the integral dx over x squared times the square root of 1 minus x squared. And this here under the radical indicates that we're dealing with a trig sub problem. We have a squared minus x squared. And because we're dealing with a subtraction, that indicates that we're dealing with a secant or a sine trig sub. Starting with a before x, that tells us that of the two, it is a sine trig sub. And so we can say x equals, in this case a is the square root of 1, which is just 1, times sine theta. In this case, the derivative of x is just cosine theta d theta. And so now we can rewrite our integrand as the integral of cosine theta up top over sine squared theta times the square root of 1 minus sine squared theta d theta. And of course, thanks to our Pythagorean identities, we know that 1 minus sine squared theta is simply cosine squared theta. And because it's under a square root, that simplifies once more to just cosine theta. And so we can rewrite this as the integral of cosine theta over sine squared theta cosine theta d theta. And of course here, the cosines cancel, so what we really have is the integral of 1 over sine squared theta d theta. And of course, 1 over sine squared theta simplifies into cosecant squared theta d theta. And this is something that you may not recognize off the bat if you haven't been practicing your derivatives and integrals of trig functions. But if you recognize that tangent theta is the integral of secant squared theta, then perhaps you can make the connection that cosecant squared theta is the derivative of negative cotangent theta. And so because we're integrating now cosecant squared theta, that is simply just cotangent theta. And because this is an integral with no bounds or limits, we must add a constant. And finally, the only thing left to do now is to recognize that this is in terms of theta, and the question began in terms of x. So we must take this original trig sub, x equals sine theta, and we must remedy the theta down here. So if we say x equals sine theta, then we can deduce from that that in our triangle, if we let this angle here be theta, sine is opposite over hypotenuse, so in this case it would be x over 1. And if we let this equal y for now, we can solve for y by saying 1 equals x squared plus y squared. Therefore y must equal the square root of 1 minus x squared. So we can put that here, 1 minus x squared. And cotangent, of course, is adjacent over opposite. And so we have minus cotangent of theta, which in this case is the square root of 1 minus x squared over x plus a constant. And this is the solution to our integral. If you have any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.